All right, so in our last lesson, hopefully we recall that we looked over how to simplify rational expressions and also multiply and divide. In this lesson, we're going to go over our last two operations, which are going to be addition and subtraction. Now, I know that in Algebra 2, rationals is one of the things that got cut a little bit short for a lot of us. So I'm going to go ahead and pretend like y'all have never seen adding or subtracting rationals. And we're going to go forward from there. So notice that I have two rationals. I have 2 divided by x plus 3 divided by x squared minus 1. Now that looks a little intimidating right off the bat. However, something that I like to go back to is just think to myself, okay, if these were just normal numbers, so like if I had 2/3 plus 1/4, what would I do to add just those? And hopefully we remember that in order to be able to add, we have to have a common denominator. And we actually want the least common denominator. So in this case, my least common denominator is going to be 12. So I have to look at, okay, what do I need to multiply my first fraction by in order to get 12? So in this case, it would be 4. So I have to multiply the top and the bottom by 4. Then I look at my second fraction and I say, okay, what do I need to multiply that denominator by in order to get 12? Well, it's going to be 3. So I have to multiply the top and the bottom by 3. So we end up with 8/12 plus 3/12, which gives us 11/12. Now that might seem like a really simple example. However, it does remind us of the process. And that process is going to be the same even for our expressions that have variables in them as well. So what we have to do is we have to look at what is going to be my common denominator. And so we have to look at things in fully factored form. So notice that my first denominator is x. That's pretty simple as it is. But my second denominator is x squared minus 1. And hopefully we've done enough factoring now that we should automatically recognize that that is a difference of squares. So we want to go ahead and factor that. So I have x minus 1 times x plus 1. So now, looking at my two factors, I'm looking at x and x minus 1 times x plus 1. If my two denominators share any factors, I only have to write that the least number of times. So if my second denominator also had an x, I would only have to include one x in my common denominator. However, in this case, they do not share any like terms or any like factors. So my least common denominator is just going to be x times x minus 1 times x plus 1. So again, kind of thinking about it the same way we did here, I'm looking at, okay, what does my first fraction need to be multiplied by in order to get that common denominator? Another way we can think about it is, what is this denominator missing in order to get my common denominator? So hopefully we see that for my first fraction, we would need to multiply the top and the bottom by x minus 1 times x plus 1. Now our second fraction is a little bit easier because it already has the x minus 1 and x plus 1. It's just missing the x. So we would have to multiply all of that out. So now, if I multiply straight across, on my first numerator, I would have 2 times x minus 1 times x plus 1. In my denominator, I now have x times x minus 1 times x plus 1. Plus, in my numerator of my second one, I have x times x plus 3. And in my second denominator, I have x times x minus 1 times x plus 1. So hopefully we can see that now my two denominators are the same. So just like we had here, once my 12s are the same, we're allowed to just add our numerators together. So notice that our denominator does not change. I'm not adding the two 12s together. The 12 stays the same. So be careful with that because a lot of times once we start adding in variables, people kind of forget some of those steps that we recalled before. So when I rewrite my new fraction, it's going to be 2 times x minus 1 times x plus 1 plus x times x plus 3. Now it's all divided by a single denominator of x times x minus 1 times x plus 1. Now, that fraction looks kind of ugly right now, and we don't really want to leave it like that. We're going to go ahead and leave our denominator in factored form. However, we're going to multiply together our numerators. So if I multiply together x minus 1 and x plus 1, we're going to end up with x squared minus 1. And then distributing that second x, I get x squared plus 3x. And my denominator, again, does not change. So then distributing that 2, I get 2x squared minus 2 plus x squared plus 3x. And lastly, simplifying, I have 2x squared plus x squared is going to give us 3x squared plus 3x minus 2 divided by x times x minus 1 times x plus 1. Now, it's going to be a good thing to go ahead and check that top and see, okay, does that factor now as well? So I would be looking at my AC method. So I'm looking for two things that multiply together to give me 3 times negative 2 gives me negative 6 that add together to give me a positive 3. Well, my factors of 6 are going to be 1 and 6, but I can't add or subtract those and get 3. They're also 2 and 3. But again, there's no combination of those that I can make in order to get 3. So I know that my numerator is not factorable, and so that would be my final answer. Now, most of the time, as long as you used your least common denominator, your final answer, once you've simplified everything, should be in simplest forms. Now, every once in a while, you will get something that factors or reduces out, but most of the time, that's just going to be your final answer. All right, next up we have subtraction, but it's going to work really similarly. The only difference that we're going to have to worry about is that negative symbol. So again, I'm looking at my two denominators. This time I have x minus 3, 3x plus 4. Neither one of those factors, so we don't have to worry about factoring, which is a little nice. But we do need to look for our common denominator. So I have x minus 3, 3x plus 4. Those don't share any factors, so our least common denominator is just going to be them multiplied together. So then again, we're looking at what is my first fraction missing? What is my second fraction missing? So my first fraction is missing a 3x plus 4. So I have to multiply that to the top and the bottom. My second fraction is missing an x minus 3, so we have to multiply that to the top and the bottom. So in our first numerator, we're going to get x times 3x plus 4 divided by x minus 3 times 3x plus 4 minus 2 times x minus 3 divided by x minus 3 times 3x plus 4. So now that they have the same denominator, we can rewrite that as a single fraction. So we have x times 3x plus 4 minus 2 times x minus 3. And it's really important to make sure that we carry that subtraction symbol with us. Because that's the biggest mistake that I see in these types of problems, is that people will drop their subtraction sign. So now again, we're going to leave our denominator in factored form. However, we do want to try and simplify the top. So distributing that x, we get 3x squared plus 4x. Distributing that negative 2, we get minus 2x plus 6. And that's going to be the really important thing. So that negative has to apply to both the x and the negative 3. Again, simplifying, I have 3x squared. I have plus 4x minus 2x, so that gives me a positive 2x plus 6. So looking at our numerator, I do have a quadratic trinomial, so we do want to check and make sure it doesn't factor. So using our AC method, we would say 3 times 6 gives me a positive 18. If there anything that multiplies together to give me positive 18, that adds together to give me positive 2, well, because none of my factors or none of my numbers there are negative, it's not going to. I can't add two numbers that are bigger than 2 and end up with 2 if one of them can't be negative. So that would be my final answer. All right, so last up we have this weird looking thing. So hopefully we remember, or maybe we don't, but now we're all going to be on the same page together, that when I have a fraction within another fraction, it's called a complex fraction. It's kind of like fraction inception. And we don't like that. We don't like having a fraction within another fraction. And it's not called a complex fraction because it's hard, because really the steps aren't super hard. It just can be kind of long. So it's going to be important that we write out our steps neatly and that we put them all there. So there are two different ways that we can kind of approach this. One is just combining our first or the top fraction and number into one big fraction and our bottom stuff into one big fraction, and then we'll reduce that way. The other is going to be to try and like multiply by a bunch of stuff, which some people like. I don't typically use that method just because it can get kind of confusing and people multiply things wrong. So you're welcome to use that method if you want to look it up. It's multiplying by the least common denominator for a complex fraction. You can look at a video on that. However, I'm just going to combine into two fractions on top and bottom. So notice that technically underneath our 3 and our 1, we have an understood denominator of 1 there. And that makes our lives a little bit easier because then I'm just looking at what is the least common denominator of x and 1. It's going to be x. So then the only fraction that's missing something is my second fraction. And then again, looking at my big denominator, again I have 1 and x minus 1. So that means that my common denominator is just going to be x minus 1. So the only thing that's missing something is my first number. So rewriting those, notice that the 2 is going to stay the same because we didn't have to multiply it by anything. Then I'm going to have minus 3x. Both of those are over x. And we can go ahead and then combine those to be one fraction that's over x. If you want to go ahead and skip this step right here and just write the combined fraction, that's okay as well. I'm just writing out all of our steps so we can all see kind of where I'm coming from. So then here, our big denominator is going to be x minus 1 divided by x minus 1. So then notice that we can simplify. So we have 2 minus 3x divided by x, all divided by, well, x minus 1 is going to give me x minus 2, and then that x minus 1 stays the same. Now, again, still not a super pretty fraction. I still have like 3 fractions there, 2 smaller fractions, and then 1 big fraction. However, recall from our previous examples when we did division, we looked at that and tried to change it to a multiplication problem. And hopefully we remember that a fraction bar is just another way of writing division. So if we wanted to, we could write this as 2 minus 3x divided by x divided by x minus 2 divided by x minus 1. And now we can do that same process. It looks really similar to one of the previous examples that we did. I'm going to keep my first fraction, change to multiplication, and then flip that second fraction. And then we can multiply straight across. So we would have 2 minus 3x times x minus 1 divided by x times x minus 2. I don't have any factors that simplify, and so that's going to go ahead and be my final answer. All right, the last type of problem that we want to look at is fractional negative exponents. Now, hopefully we recall that negative exponents mean that that would become the denominator. And so we could do this one of 2 ways. We could try and rewrite these as fractions and move these to the bottom. However, because we have like 5/2 and 3/2, that's not going to be super pretty fractions. But hopefully, we notice that here we have a common factor of an x. Now, the half stuff looks a little bit different. However, it's still going to work the same way. So let's just go back and look at something that looks a little bit more familiar. So if I had something that looked like 2x squared plus x, and I wanted to factor out a common factor of x, we'd be left with 2x plus 1. So remember that factoring is like division. I'm subtracting those exponents. So 2 minus 1 gives us a leftover 1. Also notice that we had to pick the smallest number that we had for our exponent to be able to factor out. Now, just because we have fractions and negatives here, that's still going to be the same case. So notice that negative 5/2 is going to be our smallest number in this case. So I want to factor out an x to the negative 5/2. And so if I factor out this whole thing, I'm just going to be left with 3. And then remember, like I said, whenever we factor something, it's like division. So we're going to subtract those exponents. So I would have negative 3/2 minus the exponent that we factored out, so negative 5/2. But looking at that, notice negative 3/2 minus a negative 5/2. Well, that's going to become addition. So I would have negative 3/2 plus 5/2, which gives us a positive 2 divided by 2, which is also just 1. So this just becomes x to the negative 5 halves times 3 plus 2x. And that looks a little bit nicer. Now, we do still need to take care of this because we don't want to leave an expression with negative exponents. So hopefully we remember, like we said from the beginning, that that negative moves it into the denominator. And now, since we only have one variable that has a negative, it's going to be a little bit easier to deal with. So I have 3 plus 2x divided by x to the 5 halves. And again, we want to simplify that as much as possible. So combining some of that previous stuff that we've done, hopefully we recall that 5 halves or a fractional exponent means that we actually have a radical there. So we could rewrite that as the square root of x to the 5th. And we want to simplify that, so I'm going to come over to the side and do a little scratch work. So x to the 5th, well, we could rewrite that as x to the 4th times a leftover x. And the reason we want to do that is because now this is x squared times x. So our x squared is going to reduce with the radical, and I have an x squared on the outside. And then we're left with the square root of x still on the inside. So now replacing our denominator with that, I have x times the square root of x. And it might seem like, oh, we've done a ton of steps now, we must be finished. However, be careful, because if we remember from our radicals, we don't like having radicals in our denominator. So I have a square root there, so I do need to multiply the top and the bottom by a square root of x. So I would have the square root of x times 3 plus 2x divided by, notice if I have the square root of x times the square root of x, my square roots would reduce and I just left with x. But then we still have this other x hanging out to the outside, so we would have x times x. Sorry, I dropped a squared. So going back, teachers make mistakes too. That's why it's important to catch ourselves. So notice that when I reduced this squared, I'm still left with an x squared. So this x on the outside should still have a squared on it. There we go. That looks a little bit better. So I have x squared, and then these radicals will reduce, which just gives us an x. And so we would end up with x cubed in our denominator. And that's going to go ahead and be our final answer. Now, I know that that seemed like a lot of work. However, none of those steps in and of themselves were super complicated. The only new thing was factoring out something that had a fraction in it, which is a little bit different. But after that, everything was just algebra steps. However, because we were combining factoring, fractions, and radicals, it can be a little overwhelming. So just be careful with problems that end up being a little bit longer. Just go through your steps one at a time. Look at, okay, I have a negative. I can't have a negative. What do I have to do? Okay, I make it a fraction. Well, now I have a fraction exponent. Okay, what do? I make it a radical. Okay, how do I simplify my radical? Okay, now I have a radical still in my denominator. How do I move out my radical from my denominator? So just take it one step at a time. With that being said, though, just like I did, notice that I made a mistake here. I missed my x squared. But because I had very clear steps, it was really easy for me just to go back and correct those. If my steps had been all over the place and I couldn't figure out where I substituted that in for where, it would have been really hard and I would have had to go back and scratch out a lot of my work. But if we write clear steps, it's really easy to go back and fix any small mistakes that we made.